Usually X and Y are used to describe and represent the axis, so the whole direction. The I and the J are usually used by convention to represent the unit vector along those directions. So if you take habits of using one for the other, you will definitely run into trouble in C270. And you might run into trouble with some instructor that might be a little bit anal. As far as I'm concerned, if instead of using I hat, you use X hat, if you want to stick with X and Y, no problem for me. I will understand what you mean. But for the future, for other engineering classes, I would suggest try to get used to the convention. Otherwise, depending on the instructor, depending on the book, depending on how flexible they are in notations, some people might not like it too much. Okay? Does that answer your question? Okay. So usually I is associated with X, J is the unit vector in the direction of Y, and K will be the unit vector in the direction of Z. Sure. Sorry. Ross, I'm just raising the microphone. Go for it. And then we will answer Mark's questions right after.
Hello? Maestro, can you hear me? There you go. Yes, sir. I was just wondering if you could go a little bit more into the detail on when we determine sine versus cosine. I know you were saying basically if it's always along the x-axis and the positive x-axis, we always have basically a cosine along the x and a sine along the y. But I know that there are some problems that changes, and I was wondering if you could maybe give us a couple of examples where it would actually change.
Yes. Yeah. Excellent question. Let's redo another example where we're going to use an alternative method which will allow us to use angles which are not defined from positive x going counterclockwise and see how that differs with the sine and the cosine. Yes. Let's do that right away. Before we do this, let me answer and address Mark Mending's question. When trying to find AX for an angle in question 2, do we use cosine 120? Oh, quadrant 2. Oh, okay, sorry. Okay, in order... Yes, excellent question. It's actually the same question as Ross. So let's go through this. I would like to pick another example and show you the two different methods of doing it. I usually start with this method of defining all the x's, all the angle from the positive x going counterclockwise because it's the easiest. All you have to do is associate the x with cosine, associate the y with sine. Bang, bang, bang. Once you get used to this technique, then I would suggest try to use another technique, which is the one I will show you right now. Since we're going to go into chapter 3, 4, 5, it will speed up your analysis. So start with this technique. Once you get the hang of it, then I would suggest try the other technique, which I will cover right now. This will help you gain some speed. The other technique is simple, but it is confusing at first. And the reason for this is it implies that we develop what I usually call the triangle eye, which is we need, in order for us to be able to use that technique efficiently, we need to be able to identify the correct right angle triangle that we want to use. And the problem with this is there is not just one that we can use. There are always going to be two. So let me show you an example. If, for example, I am given a vector A, already wrote B, so sorry, let's use B, which is defined that way, in the second quadrant. As I put my x and y in this direction, then if I stick with the positive x going counterclockwise, my angle is going to be between 90 and 180. Right, the angle defining B. If you use the technique we've used, and you define your angle from the positive x going counterclockwise, regardless of which quadrant the vector is at, first, second, third, or fourth, you can always associate the x with cosine and the y with sine. That's why this method is so nice. You will pick up the negative sign as you calculate the actual cosine and sine. In this case, this angle seems to be, maybe 140, say. If you calculate the sine of 140, you will always get a positive number, which confirms the fact that the by is up. And as you calculate the cosine of 140, you will get a negative number, which confirms that the bx is going left. So if you define your angles from the positive x going counterclockwise, you don't have to worry about anything. The calculator is always going to give you the correct sign. And you can always associate the cosine with the x and the sine with the y. So that's, in that sense, the safest method. That's the reason why I start with this one. Now, as time will go on, you might want to go a little bit faster and pick another angle. Or worse, the question is not going to give you angles defined as we've just used. They will give you other angles. For example, imagine that the stupid problem wants to trick you and give you this angle instead. So now you have two options. Either you redefine all the angles given to you such that they will be redefined from the positive x going counterclockwise, and then you can use the original method, or you try to attack this using the angle 30. So if we want to use the original method in this case, I will redefine my vector b. Let's say if the magnitude of b is 2, I will redefine my direction of b as theta b of 120, which is 90 degrees, the angle between x and y, plus 30. And then I can use the technique that we've used. Or I can stick with what I have, which is 30, but now the purpose of the game is to recognize a right angle triangle. So I want to decompose my vector b into two vectors, same principle. I will pick one of the two vectors to be along the x and the other one to be along the y. So the first possibility that I have is to decompose b as this vector along the y and this vector along the x. Now this one is called by and this one is called bx. So I have just defined b as by plus bx. So again, remember, when you add vector, we can use the commutativity rule. We don't have to go x plus y, we can go y plus x. Yep, exactly, Anthony. So I'm getting there. So now, in order for me to express the magnitude of my vector by and the magnitude of my vector bx, I need to recognize my right angle triangle. But this one, in this case, is easy, especially if I do a little diagram, because I know the property between bx and by, which is that they're always perpendicular to each other. Therefore, my right angle is always between the two, always here. Bang! I have nicely identified my right angle triangle. So I know now that my by is the adjacent, and therefore I is the cosine, and my bx in this particular case refers to the opposite of my angle 30, and therefore I should use the sine. And therefore, to confirm Anthony's solution, my vector b will be 2 sine 30 and 2 cosine 30. The x will need the sine right here, and the y will need the cosine. Now there is a little problem with this method, which is that we have to be a little bit more careful. This will only allow us to obtain in a faster way the magnitude, but it will not give us the direction. We have to put the negative sign that represents the direction by ourselves. So that's why it's always useful to plot it. If I plot those like I did, I know that by is going up. It is in the same direction as my assumed y-axis, which is positive up. Therefore, my by is positive, no problem. But my bx is going left. And my convention was, since I put my little arrow on this side, that everything that goes towards the right is positive. Therefore, my bx must be negative. And I need to add that up manually. Yeah. Alright? So that's the danger of this method. It is obviously faster, so that you don't have to redefine your angles. You can just recognize which right angle triangle you're going to use and just allocate or identify which was the adjacent, which was the opposite. And in this case, you've seen that the x is not the cosine, but in this case it's the sine, and the y is the cosine. But you also have to check the signs. Okay? Another solution that you could have used is, instead of using this right angle triangle, hey, if you're being given this angle, then obviously you don't want to use this one. You want to use that one, the one that includes the angle given to you. Therefore, you want to decompose your vector b as bx and by, which are exactly the same vectors as above. Because remember, the vector has two properties, direction and magnitude. So as long as you don't change the length, and we haven't in this case, neither the direction is the same vector. We can pick a vector and move it around on your plane. It's the same vector. So this by and this by better be the same, and this bx and this bx better be the same. Let's check that they are the same, even though we're using a different triangle. In this case, if you choose this right angle triangle, my bx refers to the exactly. Woo, this guy is going fast. So bx is the adjacent. So bx will be cosine, and this time cosine of the angle 60 times the magnitude. Again, we need to check the direction. So the same way as the previous one, we notice that bx going towards the left. Poof, I need to put a negative sign. And similarly, by in this case refers to the opposite side of my triangle. Therefore, I know it will be the sign, and it's going up. Therefore, positive 2. Okay. Now, in general, regardless of which method you use, once you figure out one guy, pay a lot of attention about doing it correctly, so that you don't have to think about the second one. If you assign bx to cosine, you know right away the y is sine. They can never be both cosine or both sine. So once you write your little diagram and you figure out carefully, okay, my bx is in this case the adjacent of 60. I know bx is 2 cosine 60. Then you don't have to think, and you can just write right away, my by is 2 sine 60. The only thing you have to check is the sine. So that's the reason why this method is way faster than the other one. However, there is a risk associated with it, which is the direction of each component. So it takes time to first recognize which triangle you're working with and being able to put the appropriate sign without goofing. So I would suggest start with the first method to get the hang of it. Do 3, 4 problems, get good at it, and then redo the exact same 4 problems using this method. Make sure you get the right answer and then get good at it.